So I've been working on this tower. We've got some of the redstone wiring getting done, but there's also water, a water pipe, plumbing, all of this connected from the city infrastructure. And I was thinking that there's another aspect of these buildings that we haven't really addressed yet, and that is heating and air conditioning. So I know a little bit about how house AC units work. Basically, they extract heat out of a room, transfer it to an outdoor condenser, and the heat leaves that way. I was wondering, how does that work for skyscrapers, for high-rise buildings? And so I learned about air handler units and how they work, and I figured we'd put one in here. So, at least for this first part, we're just going to build the air handler unit. We're just going to be doing the heavy-duty lifting when it comes to supplying fresh air to our building. Of course, I'm doing this in vanilla, no mods, just with the regular blocks that we have. So it doesn't actually serve any function in-game other than serve as a realistic looking aspect of what we're doing here. So I've already got a bunch of stuff that I'm going to be using to build this air handler unit, and some spots that will be going in for exhaust and fresh air. So we're going to start with this. So here is our air handler unit base. We're going to go 3 wide and 8 long. This will be the air intake and outtake side. So this part here will do our outside air intake, or OSA intake, and we're going to put these sort of curved, angled ventilation looking things. I'm sure you've seen them before. And we're going to put our damper, get it on the underside here, so that it can open it and close. So the idea of a real air handler is that this is a damper that will open and close to allow more or less air in depending on demand. So now that we've got the air intake, the first thing we're going to put in is a coarse air filter that will come in immediately after the air filter. This will serve as a heating coil connection, should our air handler have need for it. Given the environment that this building is situated in, we're not going to be using a heater element. But what we will be using is a humidifier and cooling coil. After the cooling coil, we have a fine filter, and we're going to use a stone cutter as our blower because it has a spinny element that I like to use. We could probably swap these two, it doesn't really matter. But all of this will be for our fresh air. We're going to use a dispenser here just to denote a socket for the ventilation, and then for our cooling coil. So what we're going to use for the interface for our cooling coil right here, we'll put an observer here, we'll do a dispenser here, and a dropper here, just because I like these aesthetics, and we'll get to that later. So the idea is that the air comes in, gets filtered, either gets heated if this is on, passes through the humidifier, because super dry air is not fun, gets cooled down by a chiller, which we're going to build out there, final filter, and then gets supplied to the entire building. And so air handler units are designed for each building based on their needs. From what I understand, one unit is capable of multiple floors, and our tower is 12 floors tall, which is perfectly acceptable. So the air gets cooled and then gets supplied throughout the entire building, and then the idea is that each room or zone in there, they can adjust how much of that cold air comes in. If they want it colder, they open up their own dampers, more cold air goes in. If they want it less cold, they close their damper. There's always a minimum so that fresh air is always coming in, but the other aspect is that there's exhaust air, waste air, carbon dioxide, and other pollutants that occur that can build up inside of a building. So there's going to be return air that's also connected throughout the whole building that will return to the exhaust vent, go in, and now we're going to build the top part of our air handler. So we're going to leave a gap here because some of the air does like to get recycled, so we'll have another vent here. Do the same thing with the stairs and the trapdoors. There's our other damper. Okay. So the exhaust air is a lot simpler. There's a lot less that we need to do to the air as it comes in. Put it here. So the exhaust air will come in. We'll pass through a filter and then a suction fan. So the exhaust air comes in, gets cleaned up just a little bit. The fan pulls it in, and all the waste air goes out. And this is an economizer, I think that's what it's called, or a mixing vent, where to be more economical, rather than if the air is still cold, if the waste air is still cold, rather than spending all that energy cooling down all that outside air, some of that cold air will filter down and get recycled back into the air supply. And now just for some final touches, label Air Handler Unit 1, and this looks like a nice keypad crafter, and it lights up when it's turned on, so it gives a cool visual. And then our intake vents and exhaust vents. So now though the air handler is put together, now we need to do the next most important part, which is build the chiller, which is what will be cooling down all of the intake air and supplying it to the building. We're going to use grates again because it has a nice coiled texture, and we'll give it some extra look. Connect our hot and cold refrigerant like so. Then we'll put the condenser unit and its expansion valve with its compressor, and return. Use a chain for a nice connection there. There we go. There's our condenser. And now we're going to connect the condenser actually to a water tower, or a cooling tower rather. So this will be a cold, connect it like that. Like so. Then we're going to put the cooling coils in, and in theory water should be going down all of those. And then just to cap it, there we go. So there's a cooling tower, but then we need to get the cold water in, the hot water in, whatever it is. So do that. Voila. So the hot water goes in, cools down, goes back in, and cycles, and it's just another way of removing heat. And there it is, our finished system. Starting with our air handler, which brings in the fresh air, cools it down with our chiller apparatus, and sends the whole thing throughout the building. Or rather, it will. And so this is a simplified version of how these systems actually work. Because of design constraints, I had put this on the ground floor. A lot of buildings have these on top of the roof, at the very top. If you've been to like a baseball park or a stadium or similar, you've seen some pretty massive air handling units outside, probably. But yeah, so this is how it works. Now that this is good to go, we're ready to put in the ductwork of supply and exhaust air so that people working in the building don't overheat, get all their waste air out. So there you go. I had fun coming up with this, so hope you enjoyed.